Hello everyone, I'm Madam Davin Nyaboke. We'll take you through Earth movement, especially the tectonic plates. Okay, who can remind me of the last class? Let's make our recall of the last class. We talked of the layers of the Earth. What are the main layers of the Earth? Anyone to recall? Anyone to remind us what are the main layers of the Earth? Okay, yeah, we talked of the crustal, mantle, outer core, and the inner core. I can ask a question of which layer is responsible for the movement of tectonic plates? Anyone who knows the layer that is responsible for movement of tectonic plate, or who has ever heard of it anywhere, or can remember from the last class? Okay, we talked of the mantle, especially the asthenosphere. I can pose another question. Which is the lithosphere? You can remind us of what we said is the lithosphere. Okay, we said the lithosphere is the rigid outer layer of the earth consisting of the crust and the upper mantle. Okay, in the last lesson, we studied the structure of the earth. We learned that the earth has four main layers: the crustal, mantle, outer core, and the inner core. The crust and the upper mantle from the lithosphere, which is broken into tectonic plates. These plates floats on the semi-fluid part of the mantle called the asthenosphere. This understanding is crucial as it sets the stage for understanding how these parts move and interact, which leads to various landforms and phenomena. Now, I promise that I will carry a picture with me that shows the four layers of the earth. Here we have the crust. You have seen the crust. We have the mantle. We have the outer core. In the mantle, we have the lower mantle and the upper mantle. Said, in the mantle, we have the lower mantle and the upper mantle. Then we have the inner core. As you see, my arrows has pointed it. You can see the uppermost mantle and crust. We call them the lithosphere. And the asthenosphere consists of the lower mantle. Okay, let's see our today's objective. Okay, we have to understand the concept of the plate tectonic so as to know what is the plate tectonic. At the end of the lesson, we should also explore the driving forces behind earth movement. I'll show you the tectonic boundaries. We also look at the real world examples like the earthquake and mountain formation. Here we see the evidence supporting plate tectonic and implication of plate tectonic. What's plate tectonic? Plate tectonic is the theory that the outer shell is divided into several eight pieces of plate, which moves over the Mount-Root's asthenosphere. These include, we have 7 plates. First one, we have the Pacific, the North America, sorry, the Eurasia, Africa, the South American, Atlantic, Indonesia, Australia plates. Halafu, we have the minor plates. I carried a map with me, which I'm going to show you the 7 plates and the minor plates. Sorry, I'll show you the plates. Sorry. Here we have the African plate. You can see the African plate. This one is the African plate. This one is the African plate. We have the South American plate. You can see it very well indicated with arrows. The South American plate. We have the Indian plate, the Eurasian plate, the Australian plate. We can see the Atlantic plate, the Atlantic plate, as my arrow indicates, the Southern American plate, and also without forgetting the Pacific plate, the Australian plate, see also, in the Northern American plate on the northern side of the world. We also have the Eurasian, the Arabian, the Australian. This is a map that shows the plates, and we have the smallest plate like the Cocos plate, the Joan de Focas plate, the Zanskar plate, the Caribbean plate. This is a minor plate. We have the Filipino plate. It's also a minor plate. With my map, you have seen several plates that's formed by the tectonic plates. We call them tectonic plates, and we have said we have the major plates, which are the Pacific, and with me here you can see the Pacific, you can see the Australia, you can see the African plate is the major plate, you can see the South American plate, the Northern American plate, and also the Atlantic plate. So you have seen the Atlantic plate where it's colored by color blue. Okay, let's see the causes of plate tectonic. Anyone who has ever met or has read somewhere about the causes of plate tectonic? Anyone? Okay, these causes of plate tectonic moves due to the plates move due to the force generated deep within the earth. Other classes, as you know, we have some forces that act on the horizontal earth movement and the vertical earth movement. On this, we have talked of the compressional force, which is the pushing together of crustal rocks due to force that is pushing rocks together to these results of the formation of mountain. And we said of the Himalayas mountain, and we talked of the tectonic force. Do you remember of the tectonic force? We talked of the tectonic force, which is the forces that move rocks of the earth away from each other. This forms the block mountains. Then we talked of the shear fault force, is the force that causes plates move past each other. Okay, interaction between plates causes, as I said, this the formation of mountain, volcanoes, earthquake, and mountains building. What makes the plates to move? Anyone who can think of the thing that can make the plates to move? Okay, we have the internal heat from the core. So heat causes mantle convectional currents. So in the mantle, this convectional currents, this the upwelling, meaning the rising and the cooling of materials sinking, creating the motion. As you see on my picture, on my left hand side, you can see the picture which have indicated B. And see the convectional currents. This shows how the mantle moves. This rises in cooling material sinks, creating of the motion. Or you can, a good example of the internal heat from the core can be the boiling of porridge. You can see how porridge boils. The hotter material rises while the cooler one sinks. You can see either of the water, you can see the bubbles, how it rotates. The hotter ones comes upward while the lower ones goes down. Also, for me, I prefer if you have made porridge. When cooking porridge, when it's coming to boiling, you can see how it boils, going downward, upwards in convectional manner. Another thing that makes plates move, we have the gravity and slabs pulls. Yeah, gravity causes the denser and the older oceanic plates sinks into the mantles and drag the rest of the plates along. Gravity and slab pulls, here we mean the denser and older oceanic plates sinks into the mantle and drag the rest of the plates along. The other thing that makes the plates to move, we have the ridge push. Here, magma rises at the mid-oceanic ridge, pushes plates apart. As you see in my picture, this is the mid-oceanic ridge, how the magma moves in a convectional manner. It's also like porridge. I've given you an example of porridge, how the porridge boils upwards and downwards. So the hotter one goes up while the cooler one goes down. Okay, a question on that. Which of the force do you think has the greatest impact in plate movement and why? I need someone to answer. Which of the force do you think has the greatest impact on plate movement and why? Okay, for me, I consider the internal heat from the core, which just say the hotter materials goes down with the cooler one sinks, creating a motion, or we talk of the rigid pose of the magma rising at the mid-oceanic ridge with pulls apart. This can make a great impact on the movements of plates. Here with me, I carried a video that shows the type of plates, especially the convectional, the types of plate boundaries, and we have the convergent boundary, divergent boundary, and transform fault. Those are the three types of plates boundary. We will start with the convectional boundary. With me, I carried a short video for it. Let's watch. So here it rises, mantle rocks migrate upwards, small pots of magma forms and rise upwards. New crustal is created by the intruding magma as the plates moves apart, lava eruption in the ocean. Then the plates diverge about 3 to 10 centimeter a year. This results for the formation of mid-oceanic ridge, which we have been talking of. Okay, we have said the convectional boundary. Plates moves apart. It's like the tensional force. Plates moves apart. This creates the mid-oceanic ridge at the Rift Valley. For example, we have the Mid-Atlantic ridge. As you see the Mid-Atlantic ridge or if you have heard of the Mid-Atlantic ridge, it's formed due to the convectional boundaries, like plates moves apart, creating a mid-oceanic ridge in Rift Valley. For an example, the Mid-Atlantic ridge. The next boundary, we have the convergent boundary. The convergent boundary, we said plates collides, forms mountain trenches and subduction zones. Here it's like the tensional force. You've heard of the tensional force, which forces come towards each other. So here plates slides towards each other. The force due to the force on the lithosphere that comes towards each other. Plates slides through each other, forming mountains. So of the Himalayas mountain and forming trenches like the Mariana Trench. Have you heard of the Mariana Trench that emerged recently? Yeah, we've seen the Mariana Trench, which always continue forming. So it's formed by convergent boundary. For me, you can see the trench, the mountain, the crust in the lithosphere, and the ocean crust. So due to the oceanic crust and the continental crust coming together, this force and sliding past each other, forming the mountains or the trenches. And we have the transform boundary. On the transform boundary, we said plates moves past each other. This is also like the transform. We talked of the shear and tear force. Do you remember the shear and tear force? It's also the same as this transform boundary. So plates move past each other, which causes earthquake. Out of the earthquake, an example of San Andreas Fault. So the San Andreas Fault is formed due to the Pacific plate moving past the North American plates, and then we have a earthquake in between, forming a San Andreas Fault. So you're getting me? Am I too fast or too slow? If you have a question I have raised, please you can ask a question concerning the boundaries or what makes the plates to move. Or if you have a burning question of the last class, you can also ask. Waiting for a question to pose a question. As I recall, we have talked of the boundaries, the three boundaries, talked of the divergent boundary, the convergent boundary, and the transformed, where the divergent boundary plates moves past away from each other, forming of the mountains. And we talked of the convergent boundary, where we have said an example, we have the Himalayas mountain and Marianas Trench. And we have talked of the transformed boundary, where an example is the San Andreas Fault, where the Pacific plates moves as the North American plates. It's really good where you can imagine our plate. You can imagine something moving past each other like this. We have this phone and something plugs and move past each other. So this leads for the transformed boundary. Other examples, we have said the Himalayas. We have examples of those tectonic plates, which are the results of these tectonic plates. Talked of the Himalayas, which is formed through the convectional current. This is due to the collision of the Indian and the Asia from the world's tallest mountain. This forms the world's tallest mountain, Himalayas. In divergent, we have the Middle Atlantic Ridge. This is the plate moves past each other, creating new oceanic crust. Then on transform formed, we have this one example, the San Andreas Fault. This is due to the Pacific and the American plate slides past each other, causing the earthquake. Okay, the next thing we are going to talk of is the evidence supporting this plate tectonic. First evidence, look of the fossil evidence. These fossils, similarly fossils, have been found in the continents that are now separated by oceans, like the fossils in Africa, also found in South America, or the ocean place where the scientists, when they dig the fossil, where they are looking for the fossil, they get it similar within the other plate. Then we have the geological evidence. What do you mean? What do I mean when I say the geological evidence? Here I mean like similar rocks, formation and mountain range, like the Appalachians in Europe. We have similar rocks formation in and mountain range, like you can view the mountain of this mountain, the other one we have the similar rocks. The next thing we talk of the feet of the continents. When we feed the continents, they fit in between, like when you take this continent and the other continent, they fit in between, showing that the plates were one, there were one. So here the coastline of the continents such as the South America and Africa seems to fit together like piece of jigsaw puzzle. Like when you take the Africa and South America, you can see on this corner and the other corner can fit in between. Like when you have teared a paper from somewhere, then you return it, it will fit correctly. That's the reason why I mean of the feet of the continent. The one of the evidence supporting plate tectonic. We have the magnetic strip on the ocean. Patterns of magnet strips in the ocean floor discovered through sea floor spreading, showing symmetric patterns in either sides of the mid-oceanic ridge. You can see the patterns of the spreading of sea floor spreading, like in the Indian Ocean. You can see how the pattern is. It's also in another ocean. Then we can talk of the earthquake and volcano distribution. Here, earthquake and volcanoes are concentrated along plates boundary, like in Pacific rings of fire, like when the earthquake, you can see we talked of the San Andrea, which is spread boundary in between the Pacific and the America. So when you fix the America and the Pacific, the earthquake from there, they are one. The next we talk of the paleoclimatic evidence. Here, evidence of past climates such as glacial deposit found in now tropical region like India and South Africa indicates that those continents were once. So like some continents have the same pattern of climate. That's the reason, that's the meaning of paleoclimatic evidence. Like in India and South Africa, they seems to have the same climatic patterns. So we are together. Next one, we talk of the plate boundaries. You can see we have talked of the divergent, the convergent, and the transform faults. These can be the evidence of that supports plate tectonics, like especially the transform fault where we talked of the San Andrea, where the Pacific and the American plates moves past each other, forming the San Andrea. So it's a very good example, a very good supporting point of the plate tectonic. Okay, if you can get me well, we were talking of the evidence supporting plate tectonic, and we looked at the fossil evidence. Who can explain for me? Who can remind others or remind the class what we have said of the fossil evidence? Someone, please. Okay, in the fossil evidence, you have said in continents we can find some fossils that are similar to each other. Okay, then we have talked of the geological evidence. Anyone who can remind me what do we say of the geological evidence? Okay, thank you. We have said geological evidence, rocks, similar rocks in mountain ranges have been found in different zones. Here we have talked of the Appalachians in Europe. And the third one we said of the fifth of the continent. Here was the interesting point, like we said of the Africa and South America. When you see the figure of, on the start of the class, I showed you the map. And you can see the picture of Africa, how the boundary of Africa and the corners of Africa can fit well in the South American plate. So this is the evidence of plate tectonic moves. Then we talked of the magnetic strip in the ocean floor. The magnetic strip, like in the ocean, like India and other ocean, like the flow of it, the sea flow spreading are similar. Then we talk about the earthquake and volcanic distribution, like how earthquake is formed in volcanic distribution. Next, we talked of the paleoclimatic evidence. Here we said there are similar climates, and we give out an example of South Africa and India. They have the same climate, climatic change, like the climatic pattern looks similar. Then we talked of the plate boundaries, where we talked of the convergent, divergent, and transform fault, which is a very good evidence that support plate tectonic. Hope so we are together. Anyone who has a question, please? question from the class, please. Someone to ask a question on the evidence supporting plate tectonic. Okay, I can repeat where you didn't get me well. Oh, especially of the feet of the continent. Okay, in the feet of the continent, we have said when you fit continents together, they form one thing. Like you can see the corner of some one and the other one when you fit together. And from like when you have teared a paper from somewhere, and when you return it, it will fit correctly. So this can be a good evidence that support plate tectonic. Okay, on our last thing of today, talk of the implication and effect of plate tectonics, where we talk of the earthquakes. It occurs that the convergent and transform faults, the first implication, or the effect of plate tectonic. Plate tectonic can cause earthquake. A good example of the San Andreas. Then we can talk at the convergent boundary. The collision of tectonic plates can create a large mountain range. Here we can talk of the Himalayas, the largest mountain in the world, which is the Himalayas. Then we have the oceanic subduction zone leads to formation of the deepest part of ocean called the ocean trenches. Yeah, tectonic can cause the oceanic subduction zone, which leads to the formation of the deepest ocean or trenches like the Mariana Trench. Then we have the shifting of continent can alter ocean currents and atmospheric pattern, leading to changes in climate over geological time scale. Shifting of continent, like where the continents have moved from each other or away from each other, and leads to changes in climate over geological time. Like climate of Africa cannot be the climate of South America, since when they were one, they had one climate. And we talk of the plate tectonic, explains the continent drift, the movement of continent. This the effect of plate tectonic explains the movement of continent. Okay, at the end of our class, anyone who has a question, please? A question, please? Waiting for a question from you guys. Okay, for today's class, we were talking of the plate tectonic, and we talked of what makes plates to move, and we saw different plates, the major plates, the 7 major plates, and we saw what makes plates move, say the heat, the gravitation, and lap poles. Then we talked of the boundaries, where we have the divergent, convergent, and transform fault, and we explained it well. Then we talked of evidence that supports these tectonic movement, where we talked of the jigsaw fit, the fossil evidence, the geological evidence, magnetic strip of the ocean, the paleoclimatic evidence in the plate boundaries. Okay, now if there is no one to ask a question, then give you work to do. Go and make short notes on today's topic. Ensure they are very clear and explain what we have talked today. Then an assignment that I will collect for the next class is research one real world tectonic boundary. Choose one, either the San Andreas Fault. The San Andreas Fault I've explained so many times, so it will be easier for you, or the Mid-Atlantic Ridge. Then the Mid-Atlantic Ridge. Yeah, I talked of it, or the largest mountain in the world, the Himalayas mountain. And you can remember it, the boundary that forms this mountain. So in it, write a short summary, 100 words on its formation, geological impact, the formation, right, how it's formed, like the San Andreas. I've told it's formed due to the moving of the Pacific past the American northern plates. Oh, sorry, I'm giving you answers. Then the geological impact, like after the formation, what's the geological impact like? The similarity of it, or the how did it impact the environment or the climatic change? You can explain climate of how it impacted to the climate change, how it has led to change of something and something, and so on. Thank you for attending today's lesson. Let's meet for another lesson next time. Thank you all for joining for today's class. Okay, make sure you don't forget to do the assignment that I gave you. Do the assignment. We will meet on another